All right, so on this one, we're supposed to find the absolute maximum and absolute minimum of f of x equals x cubed minus 12x on each of the different intervals. And so we're going to have an interval here, an interval here, and an interval here. So maybe first things first, let's think about the domain. The domain is going to be what? Well, the domain here is going to be all numbers. So we can go from negative infinity to positive infinity, plug it in there, and we have no problem. So we have the domain is the whole values of x's. Now let's go ahead and do what is the derivative of f of x? Well, that's going to be equal to what? 3x squared minus 12. Okay. Well, let's factor. We can pull out a 3, and that gives us x squared minus 4. And that's going to be x plus 2, x minus 2. And so our critical numbers are going to be what? They're going to be x is equal to a minus 2 and x equals a plus 2. So those are going to be our two critical numbers. And so now what we need to do is we need to say, okay, well, in all these intervals, those are going to be the values we're going to look at if they're within that interval. So if it's not within the interval, then we don't have to look at that critical number. But if it is, we have to look at that critical number. So now what we're going to do is we're going to find f of the endpoints, minus 5, f of 5. And now is minus 2 and plus 2 within that one? Yeah, it is. So then we're also going to find f of 2 and f of minus 2. Okay. So we're going to plug all those in. And so if we plug in negative 5 cubed and then minus that, that's going to give us negative 65. Now, if we plug in 5, that's going to become a more positive, and so then we're going to subtract off, and then so that looks like it's going to be f of 5 is going to be a positive 65. Then f of 2, we plug that in, that's going to be negative, and it's going to be a negative 16, and a negative 2 is going to be positive 16. Okay. All right, so now we've got all of those. Now we look at the absolutes. Well, this one looks to be absolute min because it's the smallest one possible. And this one is going to be what? The absolute max. Okay. Now we're going to do the same thing for B. So for B, we're going to look at f of a negative 3, and then next to 9, let's just do it in order, f of negative 2. That way we make sure it's all in. Then f of 2, then f of 3. Well, the negative 2 and that we have already, so we don't have to worry about those. So a negative 3 is going to be a 9. Negative 2, we said it was 16. Positive 2 was negative 16, and 3 is going to be a negative 9, if I could write that anyway. So now what do we have? Well, the biggest and smallest are right here. So this is going to be the absolute max. This is going to be absolute min. Okay. And again, we notice we changed because we have a different interval. It's not going to be those endpoints now. It's going to be something in between. And then let's do our last one. So here we're going to find f of negative 3, and then we'll have f of negative 2, and then we have what? Well, now positive 2 is too far, but we can do f of 1, and so we really only have those three we have to look at. And so we're throwing out this critical number on this last one because it's beyond our uh, interval that they want us to look at. So negative 3 we said was 9, negative 2 is 16, and if we plug in 1, we get a negative 11. So the biggest one happens to be this one, so that's going to be our absolute max. This one looks to be the smallest, so that's going to be our absolute min. Okay, so that's kind of how we're going to be working problems like this. First, we find our derivative, then we find our critical numbers, and then whatever critical numbers we have, we figure out what is the interval we're looking at. And if they're within that interval, then we just find f of the endpoints plus the critical numbers, and then find our absolute min and max. And if it's not, then we just leave it off. In the case here, the f of 2, we just leave it off, and we find everything else, and we go from there. All right, so hopefully that helps with that one. Let's come back for some more.